Now, in this lecture, let us understand what is E1CB reaction. We have already studied what is E1 elimination reaction, what is E2 elimination reaction, and what is E1CB. And now we are going to study what is E1CB reaction, elimination conjugate base reaction mechanism. Now see, we will discuss later after completing E1CB reaction mechanism. We will compare E1, E2 and E1CB. Now see, it's known as E1 elimination conjugate base reaction mechanism. Means here conjugate base is formed. E1CB means E1CB means conjugate base elimination. Now what is a conjugate base? See, if we have a compound HCl, HBr, HI or HF. Now if this bond is broken towards chlorine, it will be broken because chlorine is more electronegative. We get H positive and Cl negative. In this case, we get H positive and Br negative. In this case, we get H positive and I negative. Now see, in all these cases, this is acid and this negatively charged species is a base. This acid and base differ by a proton. It's called a conjugate acid-base pair. Now conjugate base is a species which is formed by the loss of proton. Conjugate base is a species which is formed by the loss of acidic proton. Now see what will we do in the given example. We will first form conjugate base and then do the reaction mechanism. Now see, if I treat this compound is given to me OMe, it's a methyl group. OMe, it's a better leaving group. Now see, there are hydrogen atoms present over here. Hydrogen atoms are over here present. Hydrogen is here present. Hydrogen is here present. The more acidic hydrogen leaves first. Base abstracts more acidic hydrogen atom. Let us treat it with a base. For example, ET3N, triethylamine. This is our nitrogen. It has 3 hydrogen groups attached to it. I have replaced 3 hydrogen groups by ET group, ethyl group. It becomes triethylamine. This is triethylamine. It's a base. It can abstract a proton over here. It can abstract a proton over here. It can abstract a proton over here. But this hydrogen is more acidic. Why? Because it is in resonance with this. Now it abstracts this hydrogen atom. Negative charge is created on this. Means a conjugate base is formed. A conjugate base is formed. This becomes negatively charged species. This is known as conjugate base. This is an acid because it donates proton. Since it donates proton, after that negative charge is created. This is known as conjugate base. Conjugate base. Now see what this conjugate base does. This electron pair shifts over here. This bond is polar. It can shift over here. We can get new type of species. That is this. This is our OMe. This is our single bond. This is double bond. This is single bond O negative. This is CH3. This species is called enolate. Means whenever a conjugate base is formed, formation of enolate is quite possible there. This is called enolate. Now this enolate can come back and this double bond can shift over here and leaving group leaves. Overall hydrogen has been lost over here and leaving group over here. OMe negative and H positive. We get MEOH. That's a leaving group. Elimination takes place. We get the product of the reaction. Then this double bond is created over here. And we get C double bond O CH3. This is known as E1CB elimination reaction. This is the concept of E1CB elimination reaction. It is possible wherever your possibility of losing hydrogen results in the formation of conjugate base or results in the formation of enolate. There is possibility of what? There is possibility of E1CB type of reaction mechanism. Now let us discuss E1, E2 and E1CB in a more generalized way. What you have understood up to now, let us take example. Example number first. This is example number first. This is example number second. This is example number third. Let us take example number first. This is our example number first. We have a leaving group X over here. And here we have 2 hydrogen atoms. Now see, if I treat with a weak base means ammonia. Now what happens in case when you have a weak base? First loss of halogen atom takes place or loss of leaving group takes place. When loss of leaving group takes place, what happens? Carbocation is formed. Now this is our carbocation which is formed over here. Carbocation. Now carbocation is formed, it can undergo elimination or substitution reaction. Since our bases are here present, it can abstract this hydrogen atom, result in the formation of alkene. This will be the E1 elimination product. This is called E1 elimination product. This process is called E1 elimination. In E1 elimination, first carbon halogen bond breaks down and the base is weak base. Substitution can also take place over here. We will discuss those questions in next lecture. Those questions where both substitution and elimination will take place. Now number second type of example, same question, hydrogen, hydrogen, but the base is different. Base here in this case is ET3N, triethylamine. It's a strong base, ET3N. It's a more strong base than ammonia. Then what does it do? It will first abstract a proton. Abstracting proton result. It will first abstract a proton. It will result in the formation of conjugate base. Now this is our conjugate base which is formed over here. This is halogen, negative charge comes over here. This is our conjugate base. Now the conjugate base can form a bond and this group leaves. It's called E1CB reaction. This is our E1CB reaction. This is our E1CB reaction. This is E1CB. Now if we have a more stronger base and a bulky base, then what would have happened? Then E2 elimination would have taken place. Now let us take same example and discuss with DBU. Take the same example and discuss with DBU. This is X leaving group and this is our methyl group. Now treat with DBU. DBU is a strong base. I have already shown it DB in last lecture. DBU is a strong base. DBU takes this hydrogen atom and the leaving group are lost in only one step. Therefore, it is an example of E2 elimination. Therefore, you have to compare when E2 elimination can happen, when E1 elimination can happen, and when E1CB elimination can happen. Now, in the next lecture, we will solve questions in which both elimination and substitution takes place, from where questions are asked in competitive exams, both substitution and elimination. Thank you for watching this short video. Thanks.